In this video, we're going to use dimensional analysis and a formula, two different methods, to convert a rate. So we are starting with a rate. Our order is given as a rate, but that's a different rate than what we are actually going to be administering. So we're told an antibiotic is mixed with 50 milliliters of normal saline, and that is to be infused over 30 minutes. The IV is calibrated at 15 drops per milliliter. How many drops per minute should be infused? What we're going to do first is use dimensional analysis. If you want to jump to the proportion and you are on YouTube, the YouTube page, not on a mobile device, you can click on formula to jump to that method. Remember, with dimensional analysis, we always start with an order. And our order is going to be usually written over 1, unless, of course, we're starting with a rate. So what we're starting with is a particular rate, and after our dimensional analysis is done, we're going to want our answer to be another rate. In other words, how many drops per minute. So I know right then and there, at the end of my dimensional analysis, I'm going to want drops per minute as the unit of my answer. So in order to end with a rate, we're going to have to start with a rate. And we're going to start with the rate of the order. We are told we want this 50 milliliters to be infused over 30 minutes. We know a rate is going to be an amount of volume over time. So that's what I'm going to start with. The order, we're told that 50 milliliters needs to infuse over a certain amount of time. How much time? 30 minutes. That is the order. A rate in this case is a ratio of volume divided by time. And you may have seen this formula, rate equal to volume over time. Right? So we have 50 milliliters needs to go in over 30 minutes. So what I need to do now is to use dimensional analysis to cancel out milliliters. And when I'm done with my dimensional analysis, instead of having milliliters at the top, I want drops. So let's start there. Dimensional analysis, we're going to be multiplying by these conversion factors. I want to cancel out milliliters and want to go into drops. So do I know, in this particular case, the equivalence relationship between drops and milliliters? If you look at the problem, we are told that information. You will be given the information. This is going to depend on the calibration of the IV tubing and whatnot. So here we have milliliters. We want to cancel. We are told there are 15 drops for every single milliliter. I knew milliliters was going to be in the denominator because I wanted to cancel, and I want to go into drops. If I were to stop right now, I would have drops as my unit in the numerator, and I would have minutes as my unit in the denominator. That's exactly what I'm looking for. So I'm just going to circle those because those, to me, that illustrates that's what we're looking for. So up top, if we were to take 50 times 15, we're going to put that in the calculator. We get 750. The unit in the numerator we see here is drops. So 750 drops. And in the denominator, we'll have 30 times 1, which is 30. And the unit is minutes. When I divide 750 divided by 30, I get 25. And my unit is drops per minute. So just to quickly review here what we did. When we are using dimensional analysis, we are converting a rate of an order to the rate of something else, whether we are going to be actually counting the number of drops per minute the patient will receive, or if this was milliliters per hour, maybe we're setting the infusion pump. Usually with dimensional analysis, we are just converting, in these cases here, a rate to a rate. So we're starting with 50 milliliters over 30 minutes, which was our order. That's what it needs to infuse. And we use the calibration. We use what we know about the relationship between drops and milliliters, the size of the tubing, to convert those milliliters into drops. If I wanted to use a formula to figure out how many drops per minute I need, remember the formula for infusion rates here when we're talking about drops per milliliter, drops per minute, when we're using that manual set. We have the volume times the drop factor, so let's write DF, divided by the time. So if we were to, and let me just change colors here real quick, if we were to go back and think about what we need here, in order to figure out drops per minute, usually our volume is going to be in milliliters. Our drop factor will be the drops per milliliter. And our time needs to be in minutes. These are the pieces of the formula that we need. So I know the total amount of volume that is going to be infused is 50 milliliters. So that's going to be right here. The volume is 50 mLs times the drop factor. The drop factor is the calibration. What is the tubing calibrated at? It is 15 drops per milliliter. So 15 drops per milliliter. It's not necessary to include the units when we are plugging them in the formula. In fact, your instructor may actually ask you not to include them in here, but I'm going to include them in here so we can see a relationship real quick. And then the time in minutes, this is the infusion time. We want this 50 milliliters to infuse over 30 minutes. What we're getting here, if you take 50 milliliters and multiply it by 15 drops per milliliter, what you're finding is the total number of drops. And that should make sense, right? If we were to have a picture of 50 milliliters, if every one of these dots here was a milliliter, and we had 50 of them. So here, if we had 50 milliliters, we're told that every single milliliter is made up of 15 drops. So every one of these dots has 15 dots within it, right? So every one of these milliliters is made up of 15 little drops. So what we're doing when we're multiplying 50 times 15, what we're doing is we're figuring out what is the total number of drops. This is the number of drops in 50 milliliters. So that's what we're getting. If you multiply 50 times 15, you get 750. This patient will be receiving 750 total, oops, I'm sorry, I shouldn't say milliliters. The total number of drops this patient is receiving is 750. Those 750 drops are infusing over 30 minutes. So if I were to divide 750 by 30, I would figure out the number of drops that are going in every single minute. And when you do that, you get 25, and it's drops per minute. So again, if we know the volume that's going to be infused in milliliters, we know the drop factor, in other words, how many drops are contained in each milliliter, and we know the time in minutes, then we can plug our pieces of information into this formula, multiply and divide to get our rate in drops per minute. Just be careful, because in some problems your volume may be in liters, the drop factor might be different than 15, and sometimes the time is in hours. So you may have to do a little bit of converting if you were to use this formula method.